Hello and welcome. In this class, we will discuss elimination addition mechanism and Benzyne intermediate formation. Elimination addition reactions are actually nucleophilic substitution reactions in aromatic systems. So they are actually aromatic nucleophilic substitution reactions. We have already dealt with aliphatic nucleophilic substitution reactions. But in this case, elimination addition reactions, we will be discussing the aromatic nucleophilic substitution reactions. These are those reactions which come under aromatic nucleophilic substitution reactions. Here in this type of reactions, generally aryl halides are the substrate for the reaction. And the reaction is initiated by strong bases like NaNH2, that is sodamide, or potassium amide. And the reaction is usually carried out in ammonia medium, liquid ammonia medium. So we have already said that aryl halides are the substrate. In this substrate, say this is chlorobenzene. Here, the halogen atom of the aryl halide, they are replaced by the nucleophile NH2. Nucleophile is produced as a result of this reaction mixture, reaction medium, that is sodamide in liquid ammonia. Here Cl will be replaced by NH2. NH2 is the incoming nucleophile. And the point to be noted here is that the nucleophile does not always occupies the same position as that vacated by the leaving group. Such reactions are referred to as sign substitution. That is, here the chlorine, when it is replaced by NH2, the incoming NH2 can either enter at the same position that was occupied by the chlorine, or the NH2 will, with equal probability, it will go to the adjacent carbon atom to which the chlorine was attached. So such reactions are termed as or referred to as sign substitutions. So elimination addition reactions are sign substitution reactions. The reaction actually proceeds via an intermediate called the benzyne intermediate. Actually, benzyne may be visualized as 1,2-dihydrobenzene. Benzene is formed by the removal of two hydrogen atoms at the ortho positions or 1,2 positions, and therefore we get the benzyne intermediate. The reaction actually takes place in two steps. In step 1, the strong base, here NH2 is the reactive species. Being very strong, it will abstract a proton from the alkyl halide, but from the ortho position of that carbon atom to which the halogen is attached. That is, this Cl is chlorine is having a strong minus I effect, and this renders the ortho hydrogens to be more acidic in nature. Therefore, in the presence of NH2 minus, this hydrogen will be removed as a proton and that will be abstracted by NH2 minus. Therefore, we will get a carbanion. Now, the carbanion thus formed will eliminate the halide as halide ion when the benzene intermediate is formed. That is, here the polarization takes place in this manner and the Cl will be removed as a Cl minus. We have already seen that it is a leaving group and therefore it will leave the molecule as Cl minus and we will get the intermediate benzene intermediate. Now the further reaction proceeds with this intermediate. That is, in step 2, the amide ion, that is a reactive species, that will be added onto the benzene intermediate to form a carbanion. This carbanion then abstract a proton from the solvent, that is ammonia, to form the substituted product, namely aniline. This is the reaction. NH2 minus is the reactive species. It will be added to the benzene intermediate as shown. as shown by the black arrow. Or NH2 minus can also be added to the benzyne intermediate as shown by the red arrow, and therefore we will get two types of products, and this results in the anions carbanion 1 and 2 respectively. This carbanion, it will abstract a proton from the solvent to give the substituted product. This is a minus charge. Here a proton will be abstracted from the solvent ammonia and NH2 will be removed, and so we will get the substituted product, namely aniline. And here we can see that NH2 can occupy either that carbon atom where Cl was originally present, and also NH2 can with equal probability NH2 can occupy the ortho position of to that carbon atom where fluorine was initially attached. Now, what is a proof for this benzyne intermediate participation? This can be explained as follows. When we take chlorobenzene with a labeled atom, when the labeled chlorobenzene, in that labeled chlorobenzene, chlorine atom is attached to the C14 atom, and when it was allowed to react with amide ion, nearly in half of the product, that is aniline, the NH2 was found to attach to the adjacent carbon atom to the labeled carbon atom, and the percentage yield is given in the bracket. Another proof comes from the fact that when the reaction was carried out with those substrate with substituents at both the ortho positions, that is on either side of the halogen, that is the ortho positions of the halogen atoms, they are already occupied by the substituents. Then there was no reaction at all. This shows that in order to trigger the reaction, the NH2 has to abstract a proton from the ortho positions. So the reaction proceeds by the abstraction of the ortho hydrogen as a proton by the base. So this can be explained only due to the participation of a benzyne intermediate. However, there are still other proof for the existence of the benzyne intermediate that is not covered in this video. Here we have explained only two proofs for the benzyne intermediate. Thank you.